Hey everyone, welcome back to my channel. Today I'm going to give a presentation that is a little bit controversial given the current climate. It's climate change, and I'm going to give a petroleum engineer's perspective. Before we get to the content, please be sure to like this video, subscribe so you can get more content in oil and gas and professional development topics, and please be sure to comment on the video below so I can incorporate your feedback into future videos. Please be sure to hit that notification bell when you do subscribe because I upload every Friday and every Sunday. Every Friday is a professional development topic, and every Sunday is a technical review. I want to make a caveat that all my thoughts are my own, and they're not based on any of the associations that I'm with. I also urge everyone to have a sincere conversation with energy, regardless of what side of the spectrum you are on when it comes to climate change. If we can have a sincere conversation about energy policy, maybe we can all meet in the middle, and perhaps we don't have to make this such a hot topic to where we'd antagonize each other with the other side. And I hope you guys are not doing that. With all of that being said, let's get to the content. In this presentation, I'm going to give two different perspectives on climate change. This is going to be an academic approach. Once again, I strongly urge everyone to have a sincere conversation about energy. And we should all have some sort of middle ground in order to develop the energy policies to live in the world that we want to live in. Hey everyone, as I mentioned, I'm going to give my MENSA presentation on climate change. The presentation title is called Climate Change, a Carcassonne. This is just demonstrating the two spectrums, or the two sides of the spectrum of climate change. And this was a presentation I gave a couple years ago that I posted on LinkedIn that I gave this presentation. I think this slide is necessary because we need to reorient what we're talking about, and maybe asking, are we seriously going back to the basics when it comes to this? Are we seriously trying to ask the question, what exactly is climate change? Again, this is just to reorient everybody about what we're talking about. This talk will specifically be about climate change. I have three very simple definitions. The weather is what happens at a certain place at a certain time. Global warming is the long-term trend of rising average global temperatures. And climate change specifically means that carbon pollution is warming our planet and is changing our rain and snow patterns, increasing the risk of intense storms. In the last 650,000 years, there have been 7 cycles of glacial advance and retreat. There's small variations in the Earth's orbit change, the amount of solar energy in our planet receives. And the last ice age was about 7,000 years ago. The significance of why we're talking about this. The possible causes of different perceptions of climate change and the varying solutions and what the results are. This has been equated to anthropogenic climate change, that human activity is the one to cause. The warmest global temperatures recorded in the past decade, and there's a time correlation to human activity. There's warming oceans, ocean acidification, shrinking ice sheets, glacial retreat, decreased snow cover, sea level rise, declining Arctic sea ice, and extreme high-low temperature records and high-intensity natural disasters. I'll first talk about the perceptions of climate change and why we have these differences in perception, why we have two sides of the spectrum to begin with, and everything in between. There's a University of Hamburg study that is called Situating the Climate Change, the psychological distances as a tool to understand the multifaceted dimensions of climate change meetings. They interviewed several hundred people from 3 coastal German islands, and the premise of the study is called the construal level theory. It's the social, temporal, and spatial dimensions that characterize the topic of climate change that are reflected in the mental representations of climate change. This also could influence the scientific work conducted on climate change. I want everyone to keep that in mind. How does the construal level theory work, and when it comes to different views on climate change? Construal levels mean that this is the relation between the psychological distance and the extent to which people's thinking. The more distant an object is from the individual, the more abstract it will be thought of and it would not be prioritized. The closer the object is, the more concretely it will be thought of. There are two types of construal levels. There's a high-level construal level. You're focused on the big picture, not on the details. Low level is focused on the concrete, present details. It's less essential to the big picture. Past literature has only focused on psychological distances of how people viewed climate change, not the high and low construals. I want everyone to keep that in mind as well. So there's four types of psychological distances. They're temporal, they're spatial, they're social distances, and they're hypothetical distances. Psychological distance affects the extent to which we think about an event, person, or idea as high or low level. Researchers assume that the greater the psychological distance, then the more abstract a concept is. Climate change is considered to be a global phenomenon, but give local examples to show the change from high to low construal. So interviewees would give geographically distant examples of climate change, but would tie back to local implications. So what would happen to their homes if sea levels rise? The inverse was also found, that local and present examples were used, but interviewees were able to make long-term implications for future generations. Psychological distances are not directly correlated to high or low construals, and most prevalent of psychological distances in the study are temporal and spatial, and how the transition to low construal influences individuals on how climate change is valued. Those are some of the main findings of CLT and the perceptions of climate change. So here are some of what skeptics say when it comes to climate change, and this comes from Patrick Michaels. He's a climatologist and former senior fellow of the environmental studies at the Cato Institute. The surface temperature has increased about 1 degree C in the past century and is possibly caused by greenhouse gases. There are two periods of global warming. Early in the 20th century's warming was not due to greenhouse gases because the human activity did not emit the amount of CO2 needed to heat the earth and the atmosphere. So the cause is unknown according to Michaels. But in the late 20th century, that's caused by greenhouse gases, the stratosphere temperature was dropping before El Nino in the 1990s. There are 32 families of government computer models used by the UN that overestimate the increase in global temperatures. The higher one goes in the atmosphere, temperatures are supposed to dramatically increase 7 times of what is observed. And this is a systematic error that is caused by an incorrect vertical distribution of temperature. Temperature prediction is skewed by moisture, which is influenced by tropic islands, which is 40% of our surface. In other words, temperatures are not actually that high. Another piece of literature I want to talk about is the art and science of climate model tuning. I want to provide this piece of literature because it provides transparency on how climate models are developed and tuned and discusses extensively on parametrization. There are a variety of goals for specific problems, and different models may be optimized to perform better on a particular metric related to specific goals, expertise, or cultural identity of a given modeling center. In other words, this implies bias in these climate models, and if a group wants to prove that climate change is exacerbated by human activity, the parameters they will tune will be related to human activity. So what do climate modelers agree on? There was a survey conducted on 23 modeling groups and were asked to rank 26 metrics that are important on climate modeling: the global net of top atmosphere flux and the global mean surface temperature. This implies that tuning is focused on the top of the atmosphere and surface radiation balance, and the parametrization of the following introduces biases in the model. So there's cloud microphysics, there's convection, and there's ocean physics and mixing. There's another view that I want to talk about in the skeptic version of climate change, that there's an increase in vegetation greening due to this change. In Africa, whether there's higher CO2, there's increased tree cover that leads to reduced fire ignition and burn area, providing a positive feedback to tree cover. Due to rising CO2 levels in the atmosphere, the greening increases by 2.3% per decade since the 1980s. Plants are now converting 30% of CO2 to organic matter, and despite a period of low moisture, evapotranspiration actually has been increasing since 2008, meaning that there's more greening, mostly due to vegetation dynamics, So there's disturbances in the forest ecosystem, which in this case is caused by greening. I have a couple charts here that show the increase in vegetation due to the increase in temperature. And I also want to show here that there is a change in leaf area percent per decade, and that China and India accelerated their tree planting programs, which is causing this drastic increase. So what are the implications of greening? Extra CO2 can make plants less nutritious, lower concentrations of nitrogen, copper, and potassium, but scientists do not know the true cause of why. More photosynthesis does not mean more food. Plants are pulling CO2 from the atmosphere. However, at night, plants are respiring CO2, which provides little value on crops, and it does not explain modern agricultural revolution. So here are what climate change advocates say. This is Catherine Hayhoe from Texas Tech University. She's an atmospheric scientist and a professor of political science, and she says the energy of the sun is not the contributor of rising temperature of the earth. The earth was cooling until the Industrial Revolution, or oil and natural gas production with an exponential increase in CO2. She also mentions that there are 26,500 indicators that our planet is warming, and we are adding to the greenhouse effect due to heat trapping CO2. So she provides a couple trends in her TED Talk about the energy from the sun, which was actually decreasing, and the temperature of the earth is rising. And then she shows that there's a declining of temperature before the Industrial Revolution, where there was an increase in temperature and the amount of carbon dioxide of parts per million. There are local events versus climate change. Humans are more sensitive to the environment in shaping their perceptions of climate change, so local cooling does not mean global cooling. A decline in temperatures over the past decade does not represent the overall trend in global temperature trends over time. So that's another argument that she makes, in that because there was a local decline, that doesn't necessarily mean that there was going to be a longer trend of decline. In fact, she shows that there was a stabilization of temperatures from 2001 to 2011, but that doesn't explain the increase since the 1970s. So that's where she's coming from. Here are some of the most common arguments against climate change: that climate has changed before, that the Earth has had ice ages and warmer periods with varying levels of CO2. The length of each cycle reduces the sunlight intensity in the northern hemisphere, and then you get the glacial age and more CO2 is dissolved in colder oceans. Here's the rebuttal of that most common argument. Greenhouse gases affected climate change in the past, and humans are adding greenhouse gases with CO2 emissions. Orbit-induced cycles, which are every 100,000 years, but the Earth was cooling prior to the Industrial Revolution. There were rapid changes in greenhouse gas emissions in the past due to massive volcanic eruptions, but there has not been one in the past 16 million years. Another common argument is that models are unreliable, which I've already shown before that there is an implicit bias when it comes to models. From the IPCC, or the Intergovernmental Panel on Climate Change, model results of observing surface temperatures, there are two cases that were run with or without man-made events. Anthropogenic and natural forcings made a match, and there is an association to CO2 contributions and temperature increases. So those were the main findings that came from this organization. There are other examples of climate models underestimating the summertime melting of the Arctic ice. In other words, that models can be optimistic as well. Models will never be 100% right, but models are hindcasted from past events to figure out if the root cause of climate change is before predictive. So there are a couple charts over here showing that if you add the anthropogenic change, it was matching to what we've observed in temperature changes. And then there's also another side of the glacial melting, in that some of these models were overestimating the glacial melting, and in other words, the glacial melting was not that bad of what we've observed. The red line is what the model is. Or actually, the black line is what the model is, and the red line is the observation. Another common argument is that CO2 limits will harm the economy. The rebuttal to that is current estimates of carbon emissions are generally too low. There are poorer regions that are expected to have far less income to cope with the damages than our wealthier regions, a problem compounded by the fact that they're also expected to bear more of the damages while having contributed least to the problem. Emissions costs are short-term but with long-term benefits in averting damages if mitigation is successful. High discount rates are preferred based off of the assumption that future generations get wealthier and the initial investment could have gone elsewhere. Those are some of the rebuttals when it comes to CO2 limits. Now I want to show a couple charts here. Is that there's CO2 emissions per capita, and that's coming from wealthier nations or more developed nations. And then those who contribute least to greenhouse gases that will be most impacted by climate change, there's an inverse effect in which the developing nations are going to bear the brunt of that will be impacted by the climate change. But again, it strongly depends on if the temperature increases are going to create that much of an impact to these particular nations. Here are the potential impacts of climate change on capital in the 21st century. This comes from the Department of Economics from Thomson Universities in Canada. There are two indicators of inequality, global to net capital to net income ratio, and the net capital share of income. If climate change impacts capital depreciation, then the capital to net income ratio eventually decreases over the next 200 years, which are levels not seen since World War II, which is a large depreciation of capital. If there's no mitigation of climate change, then there's capital depreciation due to damages from climate change, lower standards of living, and then there's increases in wealth and inequality gap because poor are most affected, and then there's political instability. And the limitations that the savings rate is assumed, the limitations in the study is that the savings rate is assumed, which will affect the rate of capital decline and given the economic magnitude due to damages from climate change. Again, this highly depends on whether there is going to be that big of a magnitude. So there's a question if climate change is irreversible and how long it will take. So from Forbes, there's a limit of global temperatures by 1.5 to 2 degrees Celsius from pre-industrial levels, according to the 2015 Paris Agreement. In other words, it's difficult to set a deadline on how many years it will take to reverse climate change, based on predictive modeling and not taking into account the CO2 reduction. In other words, we would be too late in the game. In other words, it's not going to take 12 years to reverse the climate change, or it's not going to take 12 years until it's the end of the world, unlike what was stated before. So mitigation and adaptation are the most plausible solutions. Mitigation is reducing greenhouse gases in the atmosphere, creating more sustainable solutions for the long term, and that would require drastic cuts from international policies. And I would say that so far only interested nations have only volunteered when it comes to international climate change policies. The more reasonable approach, I would say, is the adaptation. Given the rise in human population and activity, we need to prepare for what comes with this temperature change increase. Again, it also depends on what the implications of the temperature change increase are. There have been many models in the past that have stated that in the 21st century, things were going to be a lot worse than what they are now. And we haven't seen some of those extreme conditions that have been stated before. But I would say that adaptation is going to be what will be the solution for the short term. So what does the data really tell us? You may be asking, Yoshi, how much data did you actually show? I thought you were going to show more graphs, more pictures, rather than a synthesis. Again, this is a high-level presentation from a MENSA presentation that I gave a couple years ago, and I strongly suggest you look at some of the references that I have in this presentation. If you reach out to me, and if you ask for these slides, I'm more than happy to give them to you. So in other words, there are surface temperature and CO2 contributions in the atmosphere that are increasing, especially in recent time. Climate models, however, are dependent on what factors could influence the local environment and the most allowing various causes and temperature increases and future global temperature trends. All models are wrong, but some are useful. As information consumers, it is important to understand the context of results and findings. So do not take the models off of face values. understand what are the inputs of these models. But this does not disprove that human activity and climate change have drastically changed around the same time in world history. In other words, we can't deny the fact that there was an increase in human activity and an increase in carbon around the time of the Industrial Revolution. Whether climate change is perceived as not important or detrimental, adaptation of climate change is more probable route at the grassroots level. So what I'm saying is, whether if you believe that climate change is irreversible or not, there is going to be some level of adaptation to the temperature change. Again, if the temperature change does mean those implications of more natural disasters. That is going to be one of the short-term solutions. You can continue those policies of creating more sustainability or creating a net zero carbon world. But what I'm saying is that there's going to be some level of adaptation to this climate change. I really appreciate you taking the time to listening to my perspective and my approach to this topic. Once again, please like this video, subscribe so you can get more content in oil and gas and professional development topics, and please be sure to comment on the video below so I can incorporate your feedback into future videos. I'll add these references in the description box, and please be sure to reach out to me if you have any questions. And once again, I strongly encourage a healthy discussion on energy policy when it comes to climate change. We do not have to antagonize each other on different sides of the spectrum. Thanks once again, and I hope to see you in the next video.